Hi. I hope you guys are doing all right. I am recording, so you and your sister are there. Very good, very good. How is everything going there? Everything okay? All right, good enough. So then, let's get started, shall we? The plan there for this week is we're gonna do week 10 here. It's kind of new, but you've seen it all there before. Probability and odds. And here, I know what I need to be doing here. And start video. There we go. There we go. Hope you guys are doing all right. And now let's go. So we got probability and odds there today. Your assignment is ready to go. It's I think it's already open. It's in the assignments and exam folder and on Blackboard. I'm trying to get away. Like, you guys have been great as far as, I've been giving assignment and you guys have been doing the work, showing me your work, taking pictures, uploading it. I'm trying to do something different here. I'm trying to save some trees, if at all possible. And even if I save 5 pieces of paper, then my job is done. So the assignment is out. It's paper based, and but in this afternoon, I'm going to open up an e-portal so that you can upload your answers. It'll be a multiple choice form. So you guys have the paper copy there, and whenever you guys done, you guys can enter your answers into the portal. Okay, just trying to save some trees and get all that done. Whew. There we go. Get a little bit of air in here. There we go. Perfect. I love a fan. So what else we got? The test 2 marks, the quiz 2 marks are posted, and it was a tough quiz. Where we're at right now, it's going to be, that's the way statistics is. Everything I've taught, or I haven't taught you guys anything, you guys have taught yourself. Everything that you guys have learned is now an accumulation. And the quiz 2 was a reflection of the test 2. Those marks should be posted there. I'm hoping they're by tomorrow. It's really difficult to, Blackboard's pretty slow, and every one takes about a minute to upload. I don't know. And anyway, but those marks should be posted there tomorrow. I've sent an announcement out once or twice. We're at that time of year now where I start putting zeros. And don't be upset, please, if you see a 0 there for a mark and you know that you've done the assignment or the test or whatever. All the 0 means is that I can't find it. Like, you have to understand there that I have assignments being uploaded to Blackboard. I have assignments being uploaded to Blackboard with no names on them, missing partners' names. I've had nutrition assignments and chemistry labs being uploaded. So therefore now the assignment that should have been uploaded is now in my email. There's even a couple there that were encrypted. So I couldn't open them there from Blackboard. So it's kind of mashed potatoes. So as I understand it there, if I don't put a mark in there, you guys don't get a notification. But if I put a 0 in there, you guys get a notification, and nobody likes a goose egg. And so that's just to get your attention. Okay? 0 doesn't mean a 0. It just means I can't find it. You just shoot me an email and say, hey, Ian, I handed it in here on this date to your email. There you go. Okay, so please be vigilant on your marks. I'm doing all that I can do on this end, and the 0 is there to notify you that I can't find it. Okay, so get a hold of me if you see something funny. Other than that, though, I think we're right on track. The quiz 2 marks were a little lower, but a little lower actually means that they're kind of closer to normal, because you guys have been about 10 to 12% percent above normal, which I think is great. You know what I mean? I'm not one of those teachers there that needs a 65 average. Okay? But where we're going now, it's going to be like test 2 and test 3. Or sorry, quiz 2 and test 2. Okay? It's going to get meatier. Okay? Because there's more stuff here. And this stuff isn't too bad there today. It's probability and odds. Now, you'll see there that I've also, like assignment 2 is posted, okay, so you can start working on it. But what we have there is this week's probability and odds. Next week is our last lecture, okay? So that's where the information stops. And it's really kind of 60% we've already done. You remember those standard normal curves there that we were talking about with the standard deviation, 34%, 68%, and then 95%, and then 99.7? That's what we're doing there next week, okay? But in order to really, like we've kind of done that, we did it on quiz 2 and test 2, right? In a basic form, just to give you guys the understanding there to move forward. And in order to move forward, we got to do probability and odds, because that will carry through to next week. And probability and odds are, probability with the standard normal curve there that we talked about, that's what next week's class is. It is also posted, okay? So a little bit of advice, all right? There's nothing due for 2 weeks, okay? The assignment is due in 2 weeks, so you have lots of time. And a little bit of advice, watch this lecture, try some of the questions there that are within the PowerPoint, okay? Because that's where we're at, and have a look at the assignment. Get good with probability and odds, and do as much on the assignment as you possibly can, because I think the first half of the assignment is this stuff. The second half of the assignment is more next week. But when you've finished all of this stuff on the assignment, you know what I mean? Some people are already done. You can be done in, an hour or two if you are familiar with this stuff already. Go ahead and look at week 11 PowerPoint. Try some of the questions there. And we will do the week 11 PowerPoint there next week. Week 12 is review. Complete review. You guys can hit me with whatever questions there you want. So there's no new material after next week. Okay, so there's time. And the information is going to cut off there next week, but the information there from next week you've kind of already seen anyway. We're just going to take it a wee little bit further. All right, so that's what's going on there. I hope you guys are doing well. Your marks are good. Keep going. There's the assignment, which I think is worth, I think it's 8%. You have your quiz 3, which is week 12. That's worth 5. And then you have your final test, which is worth 20. So 28 and 5, that's what? 33% of the course is still to go. If you have a great mark right now, there is potential for disaster if you let your foot off the gas. Okay? And I don't want you to do that. So just keep going. You've only got a couple more weeks to go. Okay? The flip side of the coin, if you're not happy with your current mark, let me know. You know what I mean? I like to know these things. I like to know that I don't like to know that someone's unhappy, but I like to know that someone's unhappy and they want to get happy. So if you're not happy with your mark, let me know, because there is the opposite. There is the chance there for a complete reversal. And as I said, there's 33% of the mark still to go. If you're not happy with your mark, here's your chance. Kick it up 10, 15%, because that's absolutely possible. Okay? Other than that, I think we're all right. If you guys have any questions there, y'all can just give me a shout out. But Hello, there was a shout. I like it.
Sorry.
That's all good.
I didn't want to cut you off.
No, talk.
Okay, so one thing that I just wanted to say was that my paper part B of test 1 that I'm looking at now, I've emailed you.
Okay,
Yeah,
now
test 1
the
part B.
Natasha, if this is like an individual thing, this is being recorded, right? So
Okay, okay.
so if you wanna, we can chat after. Are you gonna be around there like this? Honestly,
Oh,
this
yeah, I'm
is that
here.
cool? All right, so don't go anywhere after
Definitely.
class.
Okay, sounds good.
All right, sounds good, sounds good. Okay, yeah, that's good. Let's go. This is what we're doing there today. We're going to talk about probability and odds. Okay, we're in no way am I promoting gambling in any sorts. You know what I mean? But just some of the things there that we use in at this time of year in this course. We use playing cards, these kinds of things, and if you're not familiar with playing cards, North American playing cards, I go into a bit of detail here about clubs and hearts and spades and diamonds. Yeah, and all that kind of stuff. But we'll get in there. All right. We're gonna. This will be new stuff to most of you, so there will be some word definitions. Okay, and it's all part of it there. We're going to talk about additive and multiplication rules there for probability. Okay, so it's not too bad. What does probability mean? Yeah, I'm just going to move this out of the way. I don't know why my picture is down here separate from everybody else's. I don't know. Anyway, let's go. Probability. And if we here we're just talking about chance. What is the chance of choosing this and not the other things in the box, right? So let's say you have two stuffies, a giraffe and a donkey. You got 5 marbles, and they're all, close your eyes and you just randomly grab one. What are the odds of choosing this one over this one? This is where we're on. This is where we're at. We've all heard, what are the odds? Well, actually, today we're going to explain mathematically what it means. But in order to do that, we'll start with probability. The number of desired outcomes, so what you're looking for, divided by the number of possible outcomes. All of them, all together. You guys have actually seen probability before. We actually called it the relative frequency, and I just included this table here. It's just from a previous lecture, yada yada, who cares, right? But you had your frequency. Remember your tally chart, your frequency here, okay? In here you had 1 out of 30, 5 out of 30, these kinds of things, and you calculated the relative frequency, okay? And these are what we're talking about. It's just another word for probability, okay? And so this is how we write it. The probability of event E happening is equal to the number of desired outcomes, what you're looking for, divided by the total possible outcomes. Everything in the bunch. So what's the probability of choosing this? Divided by everything, including that. All right, we'll get there. There is the complementary probability, which is kind of the opposite. And you'll see here we write it as P bar. The complementary probability of an event happening is the number of undesired outcomes divided by everything. So you see these are opposite. The number of desired outcomes divided by everything. The complementary is the number of undesired, what you're not looking for, total possible outcomes. Let's go. There are 4 rules here that we'll need you guys to get. The probability of an event E is a number. It can be a fraction. It can be a decimal. It can be a percent. It can even be a ratio. They all mean the same thing. I'm going to show you these, okay? But what's important here, the probability of an event E, is that this number, whatever the number is, has to be between 0 and 1. Okay? So like, let's say I have a coin and there's heads and there's tails. Okay? What's the probability of getting a head? And you see, there's two choices, heads and tails, and I was looking for a head. So 1 divided by 2 is equal to 0.5. That is your probability of getting a head, which is also the same as getting a tail. 0.5 is just another representation of 50%. Okay, I'll get into a little bit of decimals and fractions, these kinds of things here. So probability's got to be between zip and 1. Okay. 2, if an event E cannot occur, its probability is 0. So you have an example here. When a single When a single die is rolled, find the probability of getting a 9. Well, there's a dice. One die has 1, 2, 3, 4, 5, 6 sides, and it has those numbers on one of each sides, right? It's impossible to roll a 9. So the solution for this, since the sample space, I love that word, sample space is all of your options. Okay? Since your sample space is 1, 2, 3, 4, 5, 6. That's it. That's all you get. Right? It's a 6-sided dice. It is impossible to get a 9, hence the probability of the event being a 9 is 0. And then the opposite side, if an event is certain, then the probability is 1. And here's another example. When a single die is rolled, what is the probability of getting a number less than 7? Well, you've only got 1, 2, 3, 4, 5, 6. They're all less than 7. So the probability of a number less than 7 is equal to 6 out of 6, which is 1. Okay? The sum of the probabilities of all outcomes in a sample space is 1. So it's kind of this one is kind of related to this one here. And if you have a look here, sorry you can't see it. Come on. So here we're dealing with the same dice. The probability of getting a 1 is 1 divided by 6. It's one face that we're looking for. That's with the 1 on it. The probability of getting a 2, the face with the 2, is again 1 out of 6. 3, 1 out of 6, 4, 1 out of 6. You add them all up, you get 6 out of 6. So if you add up all the numbers in your sample space, it must add up to 1, which is 100%. All right? Okay. Just some examples here. This is good to know. Very interesting. The probability of an event happening plus the probability of the event not happening, the complementary, has to equal 1. And if you just go back here, let's say the probability of the event, I'm looking for a 1 on my dice. Okay, so the probability of getting a 1 is 1 out of 6. The probability of not getting a 1 is 5 out of 6. So 1 out of 6 plus 5 out of 6 still equals 6 out of 6, which is 1. That's a neat little one. You might need that one on the assignment. And you just have a look here. What is the probability of rolling a 4 using a die that has 6 sides? Well, 1, what you're looking for is the 4, which is one face, which is 1, divided by a possible 6. So you get 1 out of 6. You could write that as a decimal. You could write that as a percentage. Okay. What is the complementary probability of rolling a 4 using a die that has 6 sides? So the opposite of this one here, it'll be 5 out of 6, or 0.84, or 84%. And you'll see there that they all add up to 100. 16 and 84 is a hun. 16 and 84 is a hun. Okay. Example 3. This one here, I'll give you a little hint on it there that you guys can remember, but what is the probability of rolling a 9 using 2 6-sided dice. So now you have 2 dice, right? And what's the probability of rolling a 9? Well, just to tell you what's your sample space there? There are 36 combinations that are possible with 2 dice. Okay? Remember that one. 36. Easily Googleable. All right? So, what is the probability of rolling a 9 with 2 dice? So, okay, I could get a 4 and a 5. Or inversely, I could get a 5 and a 4. They're not the same because this is dice 1, this is dice 2. So here in this case, dice 1 rolled a 4, dice 2 rolled a 5, and in this case here, dice 1 rolled a 5, and dice 2 rolled a 4. Different bananas. All right? So you'll see there that there are 4 possibilities that are attainable in rolling a 9 using 2 dice. Okay? So, according to our probability formula, which is back here, number of desired divided by total possible outcomes. Well, I got 4 possibilities. That's what I'm looking for. Divided by 36 combos equals 1/9 or 11%. Okay? Not too bad so far. What kind of freaks people out is fractions in this part here. And you'll see there that when you open up the assignment, I'll ask for some questions to be in fractional form. I'll ask for some questions there to be in decimal. I'll ask for some questions there to be in percentage. Okay? So you've got to be able to flip in and out of these. Okay? And it's easiest if you have the fraction first. And generally, that's how you solve these. You're going to compute an answer that's going to be a fraction. And then how do we convert a fraction into a decimal? Well, you divide the bottom by the top by the bottom. 1 divided by 2 is 0.5. And then convert to a percent. What does percent mean? Times 100. So 0.5 times 100, 50%. Okay? If you have a percentage here, what does percentage mean? Out of 100. So what's the fraction? 80 divided by 100. All right? Which we can reduce to lowest terms. Okay? So 8 divided by 10. All right? And what's a number that's common to both of them? It looks like 2. 2 divided by 8 is 4. 2 divided by 10 is 5. Okay? There's your fractional form there. There's your decimal would be 0.8. Sorry, I guess that should be over there. And yeah, if you try these out, okay? The only way to practice these is just to try them out. And if you have some issues there with fractions and all that kind of stuff, don't sweat it. Shoot me an email. We'll get you going. We'll have a 10-minute WebEx and we'll get you all on your way, okay? Yeah, I don't want this stuff to be the problem. And if it is, let me know. We'll fix it. Okay? So try these out. These are good ones. Let's go. Now we'll get into some more questions here and this and that. But first I want to go over, some people are not familiar with Western playing cards. And it's okay. It's all right. There are 52 cards in a typical deck of cards. Okay? And there are 4 suits. There are hearts, diamonds. They are red. And there are spades and clubs. They are black. Okay? So there's 4 suits. Okay? Hearts, diamonds, spades, clubs. So 4 divided by 52 means that there are 13 of each card. Sorry, 13 of each suit. So in every suit for hearts, there's a 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Jack, queen, king, and an ace for each of these. So there's 13 of these there for hearts. They're all red. 13 of these there for diamonds. They are red. 13 for spades. They're black. And 13 for clubs, they are black. Okay? And please note that for each 13, there are 3 face cards only. Okay? These are all number cards. This does not have a face. Okay? These 3, they have the face of a king, face of a queen, face of a jack. So sometimes I might ask for how many face cards? Well, you got to know that total in the whole deck, there are 12 face cards. You guys have any issues with these? If these kind of freak you out or anything like this, shoot me an email. We'll get you all going, okay? So a standard deck of cards has 52 cards. What is the probability of selecting an ace from a standard deck? Right? And just the whole idea is you're like this. You're blind choosing, right? This is all random. Random. Because that's where we're going to get into there next week, okay? So, what's the probability of selecting an ace from a standard deck? Well, how many aces are there in a deck? They be 4. That's what we're looking for. The number of desired divided by the total. How many cards total? 52. 4 divided by 52 is 7.7%, or 0.077. What is the probability of selecting a red face card? Jack, queen, or king? Well, here we're only looking for red-faced cards. Well, there's 3. Okay, there's Jack, Queen, King. So when we're looking for red, so there's 3 for each, times 2 will be 6 divided by 52, which turns out to be 0.115 or 11.5%. It's okay. Good. What do we got here? 2 great definitions. And let's go back to a coin, flipping a coin, heads and tails. Okay? And we've kind of already talked about this there. The theoretical probability of getting a head or a tails. Right? Well, your sample space, okay, you could either get a head or a tail. So you've only got 2 choices. And we're looking for a head or a tail, doesn't matter, we'll just say heads. And 1 divided by 2 is 0.5 is 50%. We've seen this. So this is what we call the theoretical probability of getting a head or a tail, that kind of thing, or anything. Okay? I'm not doing a study. I'm not doing anything. I'm just calculating the theoretical probability, which is what I'm looking for, divided by the total. Empirical probability, sometimes called experimental probability. Let's say we take that coin and we flip it 5,000 times. So I'm actually flipping it, heads, and recording it. Flipping it, heads again, recording it. And these were my results. Flipping a coin 5,000 times, and I count heads 2,850 times. Whoa, I can already see something's not right here. So my probability of the event, which should be probability of getting a head, okay, 2,850 divided by 5,000 gives me, what? 57%. That's not right. But you see what's happening here, though. Your empirical probability can differ from your theoretical. Maybe the coin is imbalanced. I don't know. Maybe your thumb's imbalanced. I don't know why. I don't know what happened, but that's what you got. All right? We're going to come back to this later. But what if I flip the coin 10,000 times? What do you think would happen? What if I flip the coin 1,000,000 times and recorded everyone, all the data? What do you think would happen to that 57%? We'll come back to it. See ya. Come on, just move over. Like, hello. There we go. Okay. I like to use these little tables here. Okay, and what they'll generally look like is they'll look like this. Hey, you get back there. You know what I mean? They'll have numbers missing here. Okay, so I'll give you the data here. So here we have males and females. Here we have born in Canada, born outside of Canada. Okay, so I'll give you this information. Y'all got to come up with the totals. And I'm just going to get these back. Okay, so these are my totals here. So this was a study done. No, it wasn't. And we have males and we have females. So the total number of males in the study were 46. The total number of females in the study were 72. Okay, so, and the total people born in Canada in this study was 63. The total people born outside of Canada totaled to 55. All right, so we've got totals all over the place. We've got everything in order now. And you see what we can start breaking things down. You know what I mean? You can start comparing, which is the whole point of stats, right? And have a look here. What is the probability of being a male? Just a male. And be careful with the words here. The words sometimes, like I talked about this there. Oh yeah, it must have been before reading week. These questions here, sometimes they are not that easy to decipher. Okay, and a big part of this course is deductive reasoning, being able to problem solve, critically think. And some of the questions there, you'll see them. I'll show them to you there before the PowerPoint's over. And they can get kind of wordy, and you got to dissect it. You got to dissect these. So what is the problem? What is the probability? What is the problem of being a male? What is the probability of being a male? Okay, so this question here, is it talking about born in Canada, born outside of Canada, this and no, it's just how many males were in the study. And I could have said that, how many males were in the study. I could have, but I didn't. I just said, what is the probability of being a male? So we got to go, okay, male is here. You go to the end, 46 males total. So 46 divided by 118 is your total. And you see, this total here and this total here should add up to this number. And if they don't, you have the problem and you must go and re-add these things, okay? So what's the probability of being male? In this study, 46 divided by 118. And I didn't bother to put the decimal or the percentage, but y'all can do that, okay? What is the probability of being a female? Well, here we go. 72 divided by 118. Perfect. What is the probability of being a female born outside of Canada? Well, you got female born in Canada, female born outside of Canada, so 34 divided by 118. Good little question here. Are we using empirical or theoretical probability? And I've answered it here. See, it's an actual real fake study, and it's empirical, okay? Because, you know, just the way with, I hope you guys do take a population genetics course, or at least a course there with a bit of population genetics. It's quite amazing how genetic variability and the babies being born and males and females, these kinds of things, it's pretty much 50-50 across the world, and that doesn't reflect here. Small study, empirical data. Empirical data can venture away from the theoretical data, but I'll come back to that in a little bit. And that little bit is right now. You remember this study here with, or not the study there, where's my pennies or the coin, or where did that go? Is that here? No. Where did that go? Okay, yeah, right here. Sorry. Your theoretical probability for the coin there is 50%, get a head or a tails. Okay, but our empirical data here, I flipped the coin 5,000 times, and these are the numbers I got. And very different. But going back, if I flip this coin 10,000 times, 100,000 times, 1,000,000 times, 10 million times, what would happen to this 57%? Generally, if the coin is a good coin, it's called the law of large numbers. Okay, the law of large numbers states that you can increase the number of as you increase the number of trials, flipping the coin 5,000, 10,000, a million times, the empirical probability will gravitate closer to the theoretical. So we flip the coin 5,000 times, which you might think is a lot, and actually it is, and yeah. But if we increase that to 10,000 times, a million times, that 57% will eventually, at some point in time, grow towards 50%, which is the theoretical. Okay? Just remember here, probabilities range from 0 to 1. It's a little bit of backtrack there. Here's another little definition here for odds. What are the odds of this happening? Well, now, here's your formula. The odds of an event occurring. Now, before I go into that, go back to probability. There's your formula for probability. Probability of an event happening is the number of desired outcomes divided by the total possible, your sample space. Okay? The odds of an event happening are the number of desired outcomes divided by the number of undesired. So this is not your total anymore. This is what you're looking for. Like, let's say I want to roll a 2, right, on a dice. So I'm going to have 1 on the top divided by what is undesired? Well, if I'm looking for the number 2, that means 1, 3, 4, 5, and 6 are undesired. So the odds of getting a 2 are 1 out of 5. We'll get into there. There's an example here. But as with probability, we have fractions, okay, that we can convert to decimal and we can convert to percentage. For odds, we generally don't use a fractional form. You can, but how we speak it is in a ratio form. The odds are 2 to 3 that it's going to rain today, or it's 4 to 5 that whatever, 4 to 5, 1 to 3. You see, this is that ratio. And if you have a look here, the odds of rolling a 7 with 2 dice. Okay, and this is where we're at right here. Okay, 6 divided by 36. These kinds of things. So have a look at it, practice those. Have a look at this one here. This one kind of gives you a good little example here. Finding the odds. 11 poker chips are numbered consecutively 1 through 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chips with those numbers on it. And then I have an extra one, and I put a 6 on that. So there's 2 chips with a 6. And then there's 1 of everything else from 1 to 10. Okay, so there's 11 total. You draw a chip from, you take a chip there from random, and you find the probability of drawing a 6. So find the probability of drawing a 6. Well, what are you looking for? There's two 6s in there. So 2 divided by the total is 2 divided by 11, which is 18%. Same thing, a chip is drawn at random. Find the odds of drawing a 6. Okay, so odds of drawing a 6, okay, is 2 divided by 9, 229, right? This is what you're looking for, 2. Here we're not using the total. We're using everything else that is undesired, right? There's your formula. Number of desired divided by number of undesired. So if you want to find the probability of drawing that 6, it's going to be 18%. What are the odds? 2 to 9. And that's how we speak it. That's how we write it. 2 to 9. I think there's a second part here. Find the odds of not drawing a 6. Well, it's just the Kamose flip. Okay, 9 to 2. Those are your odds of not. drawing a 6. And you see there, your odds are much better of not drawing a 6 because there's 9 chips there that you're trying to get. So have a look at those there. Note there for percentage for odds. Okay, the only we read X to Y. Okay, this is this ratio. The odds of winning are 4 to 1. That's how we do odds, generally speaking, unless I ask for something different. But that's what we're looking for there. Questions here. There are questions put out all through the PowerPoints here. Most of them there have answers. What I'll do is later there today, I'll post the answers there for all the answers here within the PowerPoint, because this class deals with sections 5.1 and 5.2 from the textbook. If you do the odd numbered questions, they all have the answers there in the back of the book. They're fine. Do a couple of them there, but where I want you guys to focus on is the questions within this PowerPoint, okay? Because they're more aligned to it's more aligned to the assignment. It's more aligned there to the quiz there in 2 weeks, and then the test in 3, okay? So if you look at these there, Eleanor rolls a numbered cube, a dice, with the numbers 1 to 6 on it. Whew. What is the probability that the number she rolls will be a prime number? You see, we can start to throw things now. We can throw things at you here. Things there like, what's a prime number? A prime number is a number that's only divisible by itself in 1. So sample space is 1, 2, 3, 4, 5, 6. Out of those numbers, which one's a prime number? Well, 1's a prime, 2's a prime, 3's a prime, 5 is a prime. Okay, so there's 4 divided by 6, and there you go, there's your probability. So try these out. If any of them give you difficulty, let me know. Shouldn't be too bad though, all right? I'll post the answers there later there this afternoon. All right, more questions here. What is the probability of selecting a card with a heart? Okay. What are the odds of selecting a card with a red jack? Different formulas, not too bad though. Convert 12% into a decimal and a lowest term fraction. That's a good little question. I like it. These ones here, this is the next section here, the second half. Look at these questions here. Find the probability of selecting a card with a heart or a spade. So, probability of selecting a card that is either a heart or a spade. That's how it goes. I'll show you that. Find the probability of selecting a card with a 9 or a heart. Welcome to the addition rule. And here we're talking about what's the probability of selecting a card that could be either this or this. And why I'm kind of acting like an idiot and overemphasizing or, because if you see or in the question like this is what you want. This is the formula you want. Okay, it's called the addition rule. All right. When you're trying to find the probability of this or this, you use this formula. And how this works is the probability of event A or event B happening is equal to the probability of A happening plus the probability of B happening. Now, I don't know, that probably sounds pretty dumb and pretty silly, like thanks, really? But the probability of these two events, of either of these two events happening, how do you solve this? Well, you find the probability of this one, which is just using the same silly old formula, okay? Probability of this plus the probability of this. So you have to do 2 probability questions in one. But if we go to this one right here, what is the probability of selecting a card with a heart or a spade? So you look at that. I have 13 hearts and I have 13 spades. They're mutually exclusive. They have nothing to do with each other. So here I got 13 apples and 13 oranges. Nothing to do with each other. They're mutually exclusive. Okay? There's no overlap. I got 2 twos, 3s, 4, 5, 6, all the way up to aces. They don't have anything to do with each other. Easy peasy. Look at this one though. Find the probability of selecting a 9. So how many 9s are there in a deck? There are 4 9s. Or find the probability of finding a heart. Well, there's 13 hearts, right? We already know that one. But wait a second. One of those 9s, sorry, I'm wiggling 2 fingers and I shouldn't be. One of those 9s is actually a heart. So one of those cards is actually in both. So it's not really mutually exclusive anymore, right? So you have to remove one of those because it's being counted twice. I'll show you all this. I'm just kind of verbal diarrhea here, but we'll show you these right here. Okay? So to go over this again, whenever you see or, okay, you're going to want this addition rule where we're talking about 2 events happening or the possibility of either of 2 events happening. The probability of A or B occurring is the probability of A plus the probability of B minus the overlap. Now, there may not be overlap. Like in this question right here, there is no overlap. So this part of the equation would just get canceled. But if you do get overlap, and you got to figure it out, I ain't going to tell you. Okay, you got to figure it out. And if there is overlap, but there will be, trust me. And you will need this, okay? Be careful. There may be overlap between 2 probabilities. If so, you must subtract one of them. Okay, and I'll show you right here. What is the, now again, addition rule or, okay? What is the probability of selecting a card with a heart or a spade? Same banana as what we just saw. So the probability of getting a heart, 13 divided by 52. Okay? Probability of getting a spade, 13 cards, 13 out of 52. There's no overlap. No card is being counted twice. So I don't need to do that whole minus part of the equation there. So therefore, probability of choosing a heart or a spade is equal to 13 over 52 plus 13 over 52 is equal to 26 over 52, which equals to a half, which equals to 0.5, which is equal to 50%, which makes sense because we're looking at 26 of the cards out of a total of 52. Look at this one though. What is a now? And to go back to the or, well, the end of the PowerPoint there's another one there that we're going to get into called the multiplication rule, which is and. I'll get there. Now, how these tests and assignments and all these things go is, you know what I mean, they're all kind of mixed up. I don't go in order. They're all mixed up because I want you to, after you finish a question, you need to reset because you don't know what's coming next, right? It's mashed potatoes. That's how it goes. Now, you when you read these questions, there will be hints within them. Okay? So if you see what is the probability of selecting a card with a 9 or a heart, you see that word or, that's the addition rule. Okay? So what is the probability of selecting a card with a 9 or a heart? So 9s, there are 4 of them, right? So the probability of getting a 9 is 4 divided by 52. It's good. Probability of getting a heart, well, there's 13 hearts out of there, so probably getting a 13 out of 52. But there is 1 9 that is being counted twice, right? There's 4 9s over here, and we got 13 cards over here. There's a 9 here that's also over here. We need to take away 1. Like my finger puppets? There we go. All right, that's the only trick to this one here. If there is some overlap, get rid of the one that's overlapping because it's being counted twice. Don't take them both away, only take away 1. So it doesn't matter. In this case here, you'll see there that the probability of getting a heart is 13. I just took one of those away and made it 12. Okay, and therefore there the probability of getting a 9 or a heart is 4 out of 52 plus 12 out of 52 is equal to 16 out of 52 is equal to that. Okay, now if you decided to take this 1, okay, away from here, so you made this 3, and this 13, 3 plus, okay, 3 and 13 still equals 16. I'll say that again. Here in this case, I took away the extra 1 from this guy. But it doesn't matter which one you take it from, as long as you take 1. Okay? Take the one that's being counted twice. And that's how that one goes. That's your addition rule in a nutshell. Okay? Oh yeah, have a look at this one. What is the probability of selecting a vegetarian with diabetes or a vegetarian with high BP? So here we go. This is what I would give you. And I would give you space under here and space over here so that you could add your totals up. Okay? What do? Add up all the totals. You get all the spaces filled in because you can't do this if you don't have your totals. Okay? So I've got vegetarian totals. Looks like 41. Meat lover total. What's that? 49. All the people in the study with high BP. That's what? 52. And all the people in the study there that are diabetic. What's that? 38. Okay? If you add up all the numbers there, we get 90. There's 90 people in the study. Okay? So, again, what is the probability of selecting a vegetarian with diabetes or a vegetarian with high BP? There's your key word. It may not look like a key word. I'm not going to make it bold or, change the font size there to 25 so it sticks right out at you. But it'll be in there. You've got to be looking for it. And now that I've told you, you will be. So we're looking for the probability of selecting a vegetarian with diabetes. So a vegetarian with diabetes or a vegetarian with high BP. Okay? So we got 16 divided by 90 plus 25 divided by 90. Now, is there any overlap? No, they're not. This group is mutually exclusive from this group, completely independent. So 16 plus 25 is equal to 41 out of 90. Fine, there you go. Okay, that's your that's your probability of choosing a person from either of those groups. That's what we're trying to do. That's probability, right? It's like if all these people were in a bag, all right? And I'm going to close my eyes and I'm going to pick a person. It's a horrible example. Don't ever do this. And you have a 46% chance of picking one of those people, okay? That's all we're talking about. And this is pretty important stuff because statistics, one of the fundamental principles there is randomness and probability. And all of this information we will take with us there to next week's last lecture. Okay? So please don't miss next week's lecture. And also the next week, there is no lecture, but we will have a review class. Same time, same thing. Okay? All right. Same question, but a little different. Okay? Same stuff up here. What is the probability of selecting a meat lover? Okay, so meat lover. Okay, so it's those two. What is that? 50 is 49. So there's 49 here. And or a person with high BP. So I got this one and this one. Hey, wait a second. That one is being counted twice. Do you see that? So this is an example where you'll have to remove, okay? Because this group of meat lovers with high BP, they're the ones that are being counted twice because we want to know all of these guys, the probability, or the probability of all of these guys. This 27 here is being counted twice. You got to remove. Okay, so just to break it down here, there are still 90 subjects. Find the individual probabilities. So the probability of just getting a meat lover, okay, 22 plus 27, right? 22 plus 27 out of 90 is equal to 49 out of 90. The probability of high blood pressure, 25 plus 27 out of 90 is 52. But you remember there that this one here is being counted twice. So the probability of choosing a meat lover or high BP, okay, there's your 49 plus your 52, but you've got a minus 27. That's all it is, okay? So you mine it because that one there is being counted twice within here. So look, there's 127 and there's another 27. You can't count them twice, okay? Even though that 27 is falling within two groups, you can't count it twice, okay? So you remove one of those 27s, you get your percentage. Next question, okay? Ta-da! Now, have a look at this one, eh? Find the probability of selecting a king and then a queen. You'll notice my overemphasization of and then. Da, 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 da. Now, let's read that again because I'm going to follow up with this. Find the probability of selecting a king and then a queen. So I'm actually choosing two cards this time in sequence. But I choose the first card. Okay. I can replace it with replacement and then choose my card. Or I could choose my card, keep it, put it in my pocket, and then choose another card. Now I want you to think about this. 52 cards in a deck. I'm going to choose two. I'm looking for a king and then a queen. I choose, there's 52 cards in a deck. I choose one. Okay, I've got it. How many cards are left in the deck? 51. If I put this card back and then choose again, my probability will be the same, right? Because there's 52 cards. The first pick, it's a full deck. 52 cards, I choose one. Look at it, put it back, choose again, still 52 cards. So my probability will be the same if I am with this word here, with replacement. Okay, that means that before I choose my second card, I put the first card back, reshuffled them and all that, so it's exactly how it's a full deck of cards, and I choose again. Or I can find the probability of selecting a king and then a queen without replacement. And all that means is I choose my first card, put it in my pocket. How many cards are left? 51. So my probability has changed, and I choose my second card. So you're going to see with replace, you're going to see and then, you're going to see it with replacement or without. They're not bad. They're not bad. I know it sounds wordy and it sounds crazy, but let's have a look here. This is called the multiplication rule. Okay? Used when determining the probability of two independent events happening consecutively. Keyword and then. All right? Independent events are such that the outcome of one does not affect the outcome of another. Okay? They're independent here. So, here we have, and this is how we speak, or this is how we write these mathematically. The probability of event A and then event B happening is the probability of A times the probability of B. Okay? So, if we go back to the addition rule, here, the probability of event A plus event B, you're adding. Okay? But for these ones here, we're multiplying. Going to be a little different. And again, this whole counting with and counting without replacement. The calculation using the multiplication rule depends on how events are counted. You can count with replacement, putting that card back, getting that deck up to 52 again. Okay? And that happens, there's no change in probability. But if you take the card, put it in your pocket, and then choose again from the deck, you're not dealing with 52. You're dealing with 51. So you've changed the probability. So there's a little... But again, is it difficult? No. What does this mean with replacement? Subject returns to the group. Okay, and here we're talking about cards. You can talk about people. You can talk about red marbles, green marbles, whatever. Okay? But with replacement means before you choose again, you put that original one back into the deck. Without replacement, taking it and then choosing another one. Okay? Let's show you some. Here we've got smokers, non-smokers, and we've got people there with right ventricle hypertrophy and people there with left ventricle hypertrophy. Okay? Same graph, different numbers. Or, sorry, same chart, different numbers kind of thing, okay? Now, again, it's going to be mashed potatoes on a test or an assignment or whatever. You never know what's going to come at you. So, look for key words. What is the probability of selecting a non-smoker with left ventricle hypertrophy? So, non-smoker with left ventricle, non-smoker left ventricle hypertrophy right here. Okay? And then a smoker with right ventricle hypertrophy. Smoker, right ventricle, that's these ones right here. Okay? Count with replacing. So, here, close my eyes, and I'm going to pick one person. I'm going to look at the person, okay? And then I'm going to replace the person and choose again. That's all this means. All right? So finding our totals here. The totals there, which I didn't include, but there's 89 subjects, okay, in this study. Find the probability there of a non-smoker with left ventricle hypertrophy, and that's how I wrote it. Easy enough. You guys can write the same. Is 9 out of 89. Okay? So count with replacement. So I put that one back for the probability of a smoker with right ventricle hypertrophy. 25 divided by 89. Okay? So there's really no change. With replacement is the easier of the two. Okay? And then we use the multiplication rule because we have to when we see these words. And then. Okay? And you'll see here that it's 9 out of 89 multiplied by 25 out of 89. And be careful, because we're multiplying, when you're using the multiplication rule, the numbers can get kind of large. Like having 10,000 on the bottom or 25,000 on the bottom is not unheard of. So please be extra careful with calculator and utilizing the calculator in this type of a situation, okay? For the addition rule, the numbers tend to be a little smaller, but for the multiplication rule, the numbers could get massive very quick, so keep them all straight. And 225 divided by 7,921 is 0.0284, which is 2.8%. You will notice here for multiplication rule, the numbers will be very small. The calculating numbers could get big, but generally the percentages of this, like you think about what is the percent or what's the probability of choosing a king and then a queen? Well, it's not very likely, okay, that you're going to do that. So and that's what's happening here. The odds of this happening, of choosing this card this time and then choosing that card the very next time, kind of unlikely. Like there's a 97.2% chance that this event will not happen, right? This is your probability. What is your complementary probability? 97.2%, right? Good. Have a look at this one. This one here we're going to count without replacing. We're not going to put that person back. So, what is the probability of selecting a non-smoker with LV hypertrophy? Non-smoker LV. Perfect. And then a smoker with RV hypertrophy. There we go. Same question. but with replacement and without. And you see here our total still hasn't changed. It's 89. So find the probability here. 9 out of 89. That stays the same. Okay, because that's the first one to be picked. What is the probability of selecting a non-smoker with LV hypertrophy? That's the first one to be picked, so it's 9 out of 89. Same banana as last slide. Now, we chose that one, 9 out of 89, that's the probability. But we're not going to put that person back. Okay? We're going to choose again. But you'll see here that I've had 89 subjects. I do not have 89 subjects anymore. I only have 88. Because I took that person out and I've got them. So now, count without replacement there for this one here, 25 out of 88. Okay? And same banana here, you just multiply. But you'll see there that your numbers, are they have changed. Okay? And same banana as before. So that's the trick for that one. All right? And not to overkill you guys here, but these are examples there. And you know what I mean? I'll go through them right now. But this is how I want you guys to do these. And I'm overemphasizing the buzzwords and all that. Okay? Compare addition and multiplication. What is the probability of selecting a king or a queen? Well, selecting a king or is the addition rule, so that means I'm going to be adding. There are 4 kings, 4 divided by 52. There are 4 queens, which are 4 out of 52, okay, which is 8 out of 52. So the chance of choosing a king or a queen is 15%, okay? What is the probability of selecting a king and then a queen with replacement? Well, the chances of choosing a king, 4 out of 52, and I'm replacing, okay, because for these ones here, I'm choosing 2 cards. For or, I'm only choosing 1, all right? So if you see and then, that means I'm choosing 2. So the possibility of choosing a king, 4 to 52, because there's 4 kings. The possibility of choosing a queen is 4 out of 52, all right? Because I'm replacing. I choose there for the king, and I put it back, shuffle them, and then I choose for the queen. So I'm going to have 52 and 52 on the bottom. And you look at these numbers here. 16 divided by 2,704. 1 divided by 169 is equal to 0.59%. Okay? What is the probability of selecting a king and then a queen without replacement? Okay, selecting a king, 4 divided by 52, and I didn't put that king back, so now my probability of selecting a queen is 4 divided by 51. Okay, that's how that one goes. What's this one? What is the probability of selecting a king and then another king without replacement? Okay, so there's 4 kings in the deck, so I'm going to choose one. Okay, so that's going to be 4 divided by 52. Okay, I'm going to keep that, and then I'm going to try for another king. Well, how many kings are there left? Only 3. So it'll be 3 out of 51. Okay, so that's how that one works there. All right, just be careful about the question, because the question, and I can't make it any, that's just the way these are. They're kind of wordy. They're not nice to read. You've got, this is scientific. This is scientific writing. This is where we're at now, where I want you guys to get to this. And I think you guys will do just fine. Just fine. What else we got? Multiplication rule without replacement. I've just given you guys lots of, there's no answers here for these ones here, but 3 cards are drawn from an ordinary deck and not replaced. So here I'm doing 3. I'm choosing 1, not replacing, 2, not replacing, 3, not replacing. Okay? You just multiply, multiply, multiply. That's all it is. And you guys can calculate these probabilities here. Shouldn't be too bad. Just a little recap there about the addition rule. You're choosing 1 card the multiplication rule, you're choosing multiple cards. The majority of the examples there I showed you there for multiplication rule, we're choosing a king and then a queen, right? But the previous example there, what's the probability of choosing 3 jacks? Without replacement? With replacement. You'll see these kinds of things. So just practice these. You don't have to do them all. It kind of starts to click in there after a couple, okay? But these things here, you will see these on the assignment, like a little chart there where you have to fill out the totals and kind of pick it all apart, okay? Mixed bag. You guys can have a look at these questions there. You'll have a look here. An urn. I don't know why they're using an urn to hold marbles or balls here, but an urn, why wouldn't you just say a basket? A basket contains 3 red balls, 2 blue balls, and 5 white balls. A ball is selected and its color is noted. Then it is replaced, put back into the basket. A second ball is selected and its color is noted. Find the probability of each of these. So there's your scenario. They've just given you these, and now you can find the probabilities there. I'll post the answers there later today or tomorrow. Okay? And if you guys have any questions about these, shoot me an email and we'll do a WebEx. From the textbook there, isn't that great for this section here. So have a look at some of these questions there. They kind of focus on the sample space, which I don't mind. The sample space is all of your possible choices, right? Remember, your sample space for a 6-sided die is 1, 2, 3, 4, 5, and 6. There's 6 numbers in your sample space, right? That's everything. Okay, so have a look at those and have some fun with this stuff. The assignment is open now. It covers this stuff. So go and have a look at it and try and do what you can do. The first half is on this stuff, week 10. The second half is on next week's stuff, the last lecture. Okay, do not do that yet. Okay, do this stuff here and get good with this stuff, and then have a look at the PowerPoint for next week. It's already there. Okay, the entire course is already done. Okay, so go when you've done with this stuff here and you feel confident, move on there to week 11 stuff. Have a look at the PowerPoint. I'll present that there next week, but there's no reason why 60 to 70%, 75% of the next week's PowerPoint you've already seen. Okay, so it's completely doable. There's an introduction of a new formula, the Z scores. All right, but other than that, it's very, very doable. The paper copy is available now, so you guys can print it off or just do work on it from scratch there at home. And again, about 24 hours, I will post an e-portal so that you guys can upload your answers. I'm just trying to save some trees, and this course, I like to see your work, okay, and these kinds of things. So, but have a look at this and have some fun with it. The assignment's due in 2 weeks, and when the assignment is due, your quiz 3 will go out, okay, and then the week after there is your test 3, where there's no lecture anyway. But proud of you guys. You guys just keep on kicking the can, and as I said, if you've got a good mark, there is potential to tank. If you have in your mind an unsatisfactory mark, there is potential to hit the stars. Okay, there's like 33% of the mark still to go, so please do not take your foot off the gas. Okay, that's all I got there today. Get out of there. I don't know, I'm sure it's raining where you guys are. It's raining. It's yeah, it's a nice day to go for a walk, actually. What, you don't like to walk in the rain? I do. It's nice. All right, well, thank you so much. Anyone has a question, stick around. Other than that, I am going to stop recording.